Welcome to SolarWorks for Illinois. I'm Tim Montague, your host.
And I'm Anson Moran.
This is our monthly webinar on the solar industry, solar and storage. And today we're going to present intelligent monitoring systems for solar projects and portfolios. Our speaker today is Anson Moran. I'm really excited to have Anson here. He's the CEO of meteoControl North America, a pioneering solar plant performance monitoring company based in Buffalo Grove, Illinois. Anson entered into the solar energy business as the founder of Viasys Solar Secure, a perimeter security company for utility scale solar plants in 2010. Since then, he's worked on 1.6 gigawatts, yes, gigawatts, of utility scale solar projects in North America, Caribbean, and Latin America, in capacities as executive, project manager, and sales. So welcome to SolarWorks for Illinois, Anson.
Thank you, Tim. It's an honor to be here.
As we were talking before the webinar started, performance monitoring is a bit of a niche, and many of our constituents will not really know much about that. So looking forward to really fleshing this out and describing it for system owners and portfolio owners. Before you get into the heart of your presentation, what is it that brought meteoControl to North America? This is meteoControl is a German company originally, and you're now part of that expansion into North America.
Yeah, so the market potential of the United States is huge. We've come a long way in the last 10 years, but there's still so much potential. And I think it's not only North America, it's global potential, right? But the energy consumption in the United States is really high. So obviously it's an interesting market. There's challenges to this market for sure. A lot of the other global markets, there's kind of one plan, whether it be a feed-in tariff or whatnot. So it's really stable, and it's a clear market. In the U.S., it's a little bit more challenging in the patchwork of incentives from state to state. But it's growing, and we're adapting with it. So the main reason why meteoControl came to the United States is to participate in this huge market, and I think it's exciting. And what we see now, as far as the solar industry, I think will be unrecognizable in 10 years from now, both from a technological standpoint and a policy standpoint and implementation.
That's one of the things I love about the solar industry. Even though it is a mature technology, it is a very nascent industry, and we are going to see lots and lots of change, not so much in the solar array technology, but in everything around that, including monitoring and performance monitoring. So, well, with that, why don't we dive into your presentation, and we'll do a little back and forth during that. And if any of the participants have questions, you can just chat those into the chat box, and we will do we'll either answer those along the way or do some Q&A at the end. So please, you have the floor.
Thank you. All right. Intelligent monitoring systems for solar projects and portfolios. So systems monitoring, it's what we're talking about. I think a distinction should be made here on the first slide from the get-go. There's increasingly really good software that comes built into market-leading inverters for monitoring, and they're getting more and more powerful every day, and it's high-quality stuff. They're doing a really good job, these inverter companies, developing the software. But there's limitations though with the software that comes with the inverter. It's really good for managing one system and getting deep insight into what's happening in the inverter. However, if you're handling a portfolio of projects, you can't manage all those systems in one portal. So you can't really get an overview of the portfolio. What we do to separate from the inverter software, it's called a independent software vendor, where it's one platform that could manage, monitor a portfolio of many solar projects and give insight to the portfolio's performance, as well as the dig down deeper into the individual site. So with the lifespan of solar plants, 20, 25 years, it's very likely that you'll have to replace an inverter at some point. And if you have multiple inverters on one site, then it's very likely it won't be the same brand or the same manufacturer, or correction, same manufacturer, same model. So it's really helpful to have a flexible solution in order to manage all these variables over time. So there's the inverter software, and then there's ISVs, which is this class of independent software vendors that are compatible across the lines of hardware that's on the site. So who is monitoring for? I guess the simple answer is anybody who cares for the long-term success of the project. Anybody who wants the vendors on the site, the contractors, to be accountable for what was installed. The obvious job titles that are responsible for daily interaction with the monitoring system are asset managers, O&M managers, and owners or investors in the project. Could you think of anyone else, Tim?
No, I think that's good. Asset managers, O&M, and owner investors. Yep, that's about it.
I was racking my mind. I think there must be other people who would be interested in this. You know, who I think is, who would be really interested, and this would probably fall under owners or investors, in community solar, which is huge here in the Midwest, is the customers of community solar should have access to maybe the same owner investor view, to feel connected to in the end, they're the investor.
That's a great idea, and a great way to differentiate yourself as a community solar project, to give your subscribers that kind of that level of access, so to speak. You know, the other thing that you and I have talked about is I would think that the equipment manufacturers would be very, very interested in this. You know, to look at their portfolio from a third-party perspective and see how it's performing, or, you know, within and perhaps between equipment makers. But
that's a good point. I think there's definitely some interest there. I know a lot of times from asset manager perspective, they'll use this data to make the manufacturers accountable for their software or for their hardware. So over time, you know, performance starts waning on some equipment. The asset managers keeping track of the warranty life cycles of the different devices, and that's an important application of the software. So, like I mentioned earlier, the design and installation, there could be bad terminations or something that happens during the EPC warranty period, where they need to come out and do some re-terminate. Asset managers have a lot of jobs on their plate. You know, they're kind of overseeing everything and responsible to the owner investor for the plant performance in the end. And the plant performance is one part of it's monitoring. Another part is managing the operations and maintenance schedule in concert with the O&M manager, as well as, you know, back office financial duties like bookkeeping and things that fall outside of the scope of monitoring. So this is one tool for an asset manager to keep accountability for the technical side of their job.
Right.
And of course, operations managers, they're really responsible for the nuts and bolts on the site. And if there's an anomaly, they want to be the first person to point that out and not have the asset manager over their shoulder ask questions about it. They want to be in front of any potential problems and remedy them as quickly and as inexpensively as possible. So it's clear that remote troubleshooting is a huge advantage. Tim, you know the cost of a truck roll. It's not sustainable over time without some insight in what's going on.
Yeah, there's the maintenance aspect, and you want to avoid maintenance, but you also want to know when a system needs maintenance. And just for the listeners, one of the ways that this really comes into play is if a solar array, for whatever reason, is not producing electricity, that means it's not collecting incentives like SRECs, Solar Renewable Energy Credits, which is a very big cash incentive here in Illinois. And you want to know about that as soon as possible, because that translates into cash in your pocket. And there is a clock ticking. So if a solar array is down for an extended period of time and the owner is not aware of that, that can really bite them in the pocketbook.
Exactly. It comes down to plant availability, which is one of the most important metrics that everybody who's accountable for the project cares about. So this will be front and center on almost every monitoring platform. Good. So last but not least, owner investors, their job is to cash the checks, hopefully. Return on investment progress, yield forecast. They want to make sure that the forecast fits what they penciled during the design phase. So, and of course, carbon offset's always a fun thing to brag about for sure. A lot of us in the industry are in this business because we love the planet and we want to take care of it. So solar plant performance monitoring and controls. I think the next slide talks about SCADA a little bit more, but I'm going to just kind of preview it a bit. The difference between, I'll wait till the next slide, but SCADA and monitoring, a lot of times in the industry, they're used interchangeably, but I want to draw a distinction, but I'll wait till the next slide. First of all, these are the data acquisition system. This is the most basic level of function that a monitoring system can perform. And what it is, it collects lots of data, as the name implies. And it collects data from weather stations that have pyronometers, wind speed, wind direction information. There's also thermometers on the back of modules. We know that heat greatly affects, or the temperature greatly affects the efficiency of production. We also have inverter data. Probably the most important data comes from the inverter. And then there's also variables like how much is being consumed at the plant itself. So we've been really good over the last 7 or 8 years technologically as an industry, collecting lots of data. And only more recently, we've been able to apply analytics, data analytics, in order to really make sense of the data in a meaningful, actionable way. In a lot of markets, power control is really critical. As the industry, as a solar industry, especially early on, we took a lot of criticism from utilities and grid operators about our effect on the grid. So in response, we have a lot of tools now in order to perform curtailment, ramp up and ramp down, and now storage control will be a huge influencer in projects moving forward. I know a lot of developers, almost every project they have in the pipeline, or some have some storage component in it, depending on the market that the project is in. But we're going to see that more and more this storage control and power control being a big influence in projects and whether projects are viable. I just want to point out this diagram over here. So what we have is the inverter over here next to number 2. I'll call number 5 a power bank. And we also have, or correction, storage. And then we have a data logger on site that, as the name implies, collects the data. It also could provide power control as well in the same device. Calling it a data logger is maybe selling it short. I would more call it a plant controller, I think is a better term. So one of the great values of monitoring is able to visualize this data. You know, we talked about a lot of the sources that data comes from, but to make it actionable, you need to visualize the data. And maybe I should have said this earlier, but the value of a monitoring system in large part is saving the owners, operators, asset managers, O&M manager time. And when you save people time, then you're saving the company money, right? So, and the value that I expressed about having a ISV versus inverter monitoring platform is that you could look over a portfolio. And in the top left-hand corner, this part of the graph here, we see a bunch of bubbles. This is kind of an example of how ISV saves time and money. This is a portfolio view. Every single one of those circles is a solar plant. The little circles are little plants. The big circles are big plants. If the performance ratio, if it's red, it's below 50% performance ratio. Yellow, it's above 50, and if it's green, it's above 80. So just by glancing at this at the beginning of the day, an asset manager could set his priorities for the week and set his priorities for the O&M manager at a glance without looking at anything else. I would look at to the far right at a big, so all the red circles are small. They're small plants. So I would look at the big yellow, at the big yellow plants that just set as a priority, because that's where you're losing the most yield. And then you could dig down a lot deeper into that, but as a setting priorities for maintenance priorities for the week, it's a really good overview. The other important thing that I think is more on the O&M manager side is managing alarms and events. This right now, the current technology, this is something that's going to change drastically over the next year, but there's alerts generated from lots of different places within the solar plant. And different owners and operators could prioritize alerts from some places over others. For example, maybe temperature, or that's not a good example. Probably an inverter function. you'd want to know about before you want to know about well, like irradiance anomalies, for example. So it's really critical to prioritize which alarms to act to first. And a lot of these this key information are key performance indicators, KPIs, and you'll hear this acronym a lot when people talk about monitoring. And kind of every company will set up their workflow differently for their company. So there's no right way or wrong way to do this. It's really a matter of experience and your portfolio that's unique and not the same as, you know, another company's portfolio. So the analytics have been probably the greatest addition to monitoring over the last 10 years. It really, you're able to drill down to the root causes. We're looking at a portfolio view now over here, but to be able to drill down to the root cause reduces the cost of the truck roll, because the truck's going out there to fix a problem, not look for a problem now. It's all this sensor data, we're able to compare it to, it's able to be compared to previous year's data with similar conditions to see where the anomaly is. Is the pyronometer broken maybe, or the reference or monitoring cell, or is there a bigger problem? Weather forecasting, I think, it's an interesting topic. Weather forecasting, probably most important to asset managers and O&M to look at. I have a customer in the northern latitudes who has a challenge. He had snow on his modules, and he saw after the snowstorm, the next week was going to have really high irradiance. And he was mulling back and forth the idea of, it's kind of expensive to get someone to go out to the site and clean the snow off the modules, but the irradiance on these next 8 days, is it going to be cost effective to send someone out there to clean the snow off the modules, or should I just wait for it to melt after maybe the second or third day of high irradiance? And by quantifying the value of that irradiance, you're able to make an informed decision on difficult decisions like that, and be able to back up your decision.
So Anson, I love this this dashboard that you're showing here, and let's bring it down to earth a little bit for the Illinois market, which is going to be dominated by community solar and C&I. But let's just talk about community solar for a second. Say I'm a solar developer. I'm going to have a portfolio of, say, 25 projects, 50 megawatts AC of solar. When you think about installing your tool on 25 different sites, what is that process like?
Yeah, so the process starts with establishing the physical location of the site. Then we look at all the different pieces of hardware that are involved in the project. Look at the drawings so we understand the layout. So we at first it's kind of a consultative discussion. We look at what the project is penciled to do, and then we make a suggestion. We think this is what you need, and we look at, there's X amount of weather stations required for X amount of capacity. And so we'll make a proposal for that, provide some drawings, and talk to the owner, operator, whoever's responsible for the long-term success of the plant, and learn about their workflow as well. We'll share with them what we think our KPIs are, but we want to hear what their KPIs are and what their workflow. So when we do the installation and set everything up, then we'll go into the web portal with them and ask how they structure their day. And then a lot of the systems are doing this now. I think we're early in market and making the system really flexible. And future proof. So yeah, so it's more of a consultative and making the system fit your business, not making your business fit the system.
And is your tool installable after an array is completely commissioned, or do they need to plan for this up front?
No, we do retrofits for sure. It's a little bit more challenging to do retrofits, but it's not a problem. We always like being the first one in new builds. Maybe it's because they're easier and we're lazy, but retrofits are completely possible. And one of the cool things, Tim, in the industry that I've seen, it's actually a trend maybe since about 2017, is that most of the monitoring companies, the ISVs, are really working well together. For example, maybe 30% of meteoControl's fleet customers' portfolios are on third-party hardware. We manufacture our own solar plant controller, but our solar plant controller supports, I don't want to use competitors, but the other players in the ISV market. So we're doing really good at interchanging. And so it's possible that if in a retrofit case like you brought up, that we don't have to change the hardware at all. We just simply change the platform that it's reporting to.
Great, thank you.
Thank you. So at the very bottom here, I talk about, I just put reporting in there, and it's kind of the bane of a lot of people's jobs. As in my position, it's a lot of reporting. I've talked to asset managers and O&M people, and they can spend anywhere every Friday, maybe 4 or 5 hours every Friday just doing reporting. And this is a key feature that's in most ISV software platforms, but how flexible and how flexible it is varies from platform to platform. So I told you I'd talk about SCADA. I had to address it. In our market, I don't really see much SCADA going in Illinois. It's really for mega size utility scale solar plants, and I don't know. It's kind of, we had a discussion internally. In the past, our company's always been local SCADA and monitoring. There's a clear divide, and we talk to people every day, and they say, "Oh yeah, we're looking for SCADA," and then you start kind of peeling back the onion, and what they really need is monitoring. But and then I was doing some. I decided to test it on Google, so I started Googling solar plant monitoring, and you get very few hits. But if you Google SCADA, then all the players come up. So it's
so besides the size of the plant that it's applicable to, what are some of the differences between SCADA and performance monitoring?
The main characteristics of SCADA is that it's local SCADA. It's all on site. Monitoring happens in cloud servers, somewhere off site, but local SCADA happens on site. There's HMI, a computer on site, servers, and there's actual control over the site with relays and industrial automation controls. So the people who need SCADA are people who need really high security requirements. So that tends to be larger projects. They have staff on site during business hours to actually manage the solar plant in real time, and it's also possible. It's also important to use if there's no internet connection. I think that's less and less. Pretty much more. Most solar plants are connected to the internet these days. So those are the main characteristics. There's also the ability of grid operators to access the SCADA system remotely.
Got it. Thank you.
So, but I don't want to talk too much about this because most of us won't run into it. But SCADA and monitoring are not the same thing. All right. So let's talk about asset managers. We kind of touched on it at the very beginning. Asset manager kind of needs to fly over the whole operation, commercial and technological and have their eye over the whole solar plant and all the contracts and everything that surrounds it. They have their technical management side, and then they have their commercial management side. And at any minute, like the Eagle, they need to be able to dive down and get really granular details. The important duties: ensuring portfolio is performing as forecasted, schedule contracts, a lot of the things we already spoke about, but also commercial financial management, manage relationships with stakeholders, and also keep up with the political climate that their portfolio or projects are in. We take for granted all these great incentives that are driving the market, and but these things could change in an instant, for better or for worse. We saw in the recent midterm elections a lot of potential changes. Luckily, most of them look like they're for the good, but it could easily go the other way. So as industry, we need to be flexible and stay on top of these things, and that's a big part of asset managers. They need to react early and react early to these changes. So we talked about KPIs for asset managers. Without being on a technical level, that the important things they need to know are, they're using it for accountability, reaction times of the operator, invested time per asset, number of tickets per portfolio, or is the O&M manager knocking down the tickets and with the best priorities in mind. So again, we're looking at accountability of the rest of the internal working functions. O&M manager, it's got to be it's a really tough, important job, the O&M manager. In the end, they're responsible for really digging down into the data and understanding what the data's telling us. Hopefully most of the O&M manager's job is preventative maintenance. We talk about things like well, like inverter servicing, inventorying, spare part management, in order to reduce the replacement time in the case of a total failure of a piece of equipment. Maybe I'm jumping ahead again, but there's really interesting technology coming about predictive failure of components. That'll be a big part of the next decade. But at the moment, they really need to be able to understand the data and again, reports. Not only O&M managers are responsible for reporting on the performance, but also the services that they do. And again, they're accountable. They're accountable through the platform as well. I didn't put it on here, but an important piece of the O&M manager is probably the most important piece is the worker safety. And it's a dangerous job, make no mistake, being on site with all those electrons moving around. The O&M manager really needs to keep an eye on the steps that the boots on the ground are taking, and make sure all that is documented, that the safety steps are being taken. So in most ISV software platforms, there's also a document management section where with apps, so the O&M team could review the safety information before performing a service on an inverter, say. So the KPIs for O&M manager, I made this graph really big because it's one of my favorite graphs. I think it contains so much information with one glance, kind of a historic information. I'll kind of briefly describe this graph. So we have the translucent red, yellow, and green. Red is poorly performing. Yellow is less than optimum performing, and green is in the 90 to 115% PR. And the yellow triangle tells us where the simulated power, based on the simulation, what the productivity should be. So you can see all these months. This is a really well-maintained solar plant. You can see that in January, February, the plant actually performed above expectation, and only in September it performed just shy of expectation. So as an O&M manager, this would be on the top of my custom report to the investor and the asset manager. Look what a great job I'm doing. This is a really cool tool. I don't think a lot of ISVs have this. This is more something. It's kind of a feature that our company pioneered. It's a heat inverter map. So it's not actually the temperature. It displays the production values in a heat map format. Again, we talked about being able to take a quick glance at a visualization of data and be able to understand or maybe have some insight into what's going on. Excuse me. So let's look at this top right one briefly. I kind of put a hint up here at the top what happened. Looking at the power AC normalized at the bottom, you can see the higher power production is more yellow to white and lower is red. So this graph represents one day from 8 a.m. to 1700. And normally what we would see is kind of a really even gradient in a well-performing inverter. An even gradient or multiple inverters. Actually, this is multiple inverters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if all the inverters are working working well, they should be working the same, and it should be a really even gradient across. You could see at about 10:30, the inverter completely shut down, and then it didn't pick up again until just before 2 o'clock. So just by glancing at this, I could see all the inverters on this plant shut down. Maybe it was scheduled maintenance. It's not clear to me. But on the portfolio view on the first page, it kind of gives a quick overview, and this is what I saw when I was putting together this slide presentation. Up here at the top, this is not part of the same graph, but I saw this gap. This is one's irradiance, and the other is the other production. The other is production, and I noticed this gap. What happened here? Was it internet? Did it lose internet or something? And I looked at it, and clearly the inverter was shut down for some reason. So hopefully it was scheduled maintenance. And then we could talk, then in the bottom left-hand corner, this is a string inverter. This is a string inverter heat map. And every one of these little lines is a string inverter. And we talked about that even gradient that we want to see. We see some anomalies in these red streaks. This inverter is completely not working at all. And one of the really cool advantages of the string level heat map is now when we roll that expensive truck to site, we could go directly to work on inverter 337. We don't have to look around and do diagnostics and search for what's wrong. And then we could also look at what happened over here with these dark spots and these streaks. We could probably also plan on maybe these inverters failing sooner than the others. So I hope I'm not getting too nerdy. Am I getting too nerdy, Tim?
You're pretty down in the weeds, but that's cool.
All right. It's just exciting. I think it's cool stuff. These tools.
I mean, anybody who's managing a portfolio of inverters can totally appreciate this.
Yeah.
So
I hope you're out there.
It is a huge time saver if you know exactly where the problem is occurring.
Yeah, absolutely. Good. So the owner investors, I make the joke that their job is to cash the check, but they want their portal too. And I think this would be really cool. Like this view would be really cool, like I said earlier, for community solar customers. and I want to do and I think this would be a really good driver for signing up subscribers as well. If subscribers knew that they had access and feel part of the project, I think it would drive subscribership for sure. So we talk about the current system. There's some information about weather, performance ratio, 82%. System availability. I talked about this being the most important statistic of all, is system availability. Is it producing? Okay, if it's not producing enough, that's one thing. But if it's not producing anything, that's a whole nother discussion. Then it probably won't be a comfortable one. It's nice to see some information about the system that you're looking at. So in the system profile, they can also have the manufacturers of the inverters, manufacturers of the modules. This view is customizable in our platform, and some of our friends at other ISVs are customizable as well. And a lot of this is driven by the asset manager. They have a better feeling of what the owner or investors want to see, what's important to them. But this is kind of a default information that we think is pretty compelling. Carbon offset, and even number of trees. The projection is also important. They want to see, okay, well, we're at 82%, but the irradiance is really poor this time of year. Let's make sure we maximize it before we maximize our performance ratio and take care of whatever is keeping it from being 100% before the biggest irradiance months come historically. So we could look at specific versus projected. Again, this is a pretty hot portfolio. I think only January underperformed. So as an investor, you'd be pretty happy to see this view. All right. So I talked a lot about what monitoring is today, but I want to look a little bit at what monitoring is going to be tomorrow. And I keep using the internet as an example. Like, Tim, do you remember like when you made plans with a friend before cell phones or before internet? You said, okay, let's meet here at this time and we'll go and have lunch or have some coffee. And then if you left your house and you got there and the person didn't show up, maybe they had an emergency and they called you at your home phone after you left the house. Oh, well, I guess I'll call them later. I'll go find something else to do. Or, it's I couldn't imagine. And I'm sure you couldn't imagine how much cell phones and the internet would change our daily lives. And I think it's still kind of tough to comprehend how deep learning and artificial intelligence will change our lives moving forward.
Yeah, I think it's a good analogy, and just to think of how the internet evolved, starting back in say '95, and what little we could do with it then, and how people poo-pooed the future of it. And then you fast forward to today and how there's whole industries being born, like social media, gigantic industries. So,
for better or worse, we'll
see.
See.
Indeed. There is a double edge to technology. You mentioned AI. I mean, I'm a big fan of AI, safe AI. And, I'm curious, is there an opportunity in performance monitoring for, say, machine learning where the monitoring system will make proactive suggestions to a system owner in a way?
That's exactly what we think the first applications will be. We think the first application, the most actionable application, is with alarming. Alarming's not a real sexy topic, but today you get an alarm is raised somewhere in the solar plant, and you'll get an alarm about, okay, what caused that alarm. We could customize alarms, but basically maybe the PR fell below a certain level, or irradiance data is disappeared, or kind of this matter of fact on or off type information. We envision a world where the system. The other point is that a lot of times you'll get something will go wrong in the solar plant and it'll cause a cascade of alarms, and then you go through all these alarms to kind of identify what the root cause is. So we envision a world where the alarms kind of like a Siri, or excuse me, how can I help you? And I noticed a failure. The root cause is actually not clear. Do you want to know more? And it actually prompts you and drills down to what the root cause intelligently, saving you, again, time and money. So maybe it's not a big failure at this point. Maybe it's a small one. You can continue to observe it. You could look at historical data, really get an intelligent analysis while you're still performing your other work. So in this case, in this example, it compared the behavior with, or the failure with every other, or with different years or different data sets, and it looks like the probable cause is row shading during fall. So, data intelligence, we'll talk about machine learning integration, and I expect, like, really in 2019, this will be in the market, data intelligence, in a big way. And it takes a lot of different disciplines and kind of matches it together with this new technology to create value for the stakeholders. You know, this fully automated detection of plant issues, we believe, will revolutionize the industry. And it won't just revolutionize the ISV market, it will revolutionize the solar market, because what you're doing is you're reducing the O&M cost of a solar plant. And this is the most sensitive thing in our business. I think a lot of you know, we pencil out these projects from a capital expense, an operation expense, and the dream is that solar is you build it and forget it, and it's going to be a lot closer to that dream with the introduction of this technology. I know we're getting close to the end here, so I'll just kind of describe a couple quick things about how we think this data intelligence will be applied. You know, like identifying anomalies intelligently that don't fit the expected pattern. Hybrid interface with statistical and physical models, weather models, all behind the scenes, so you don't have to be a meteorologist or have a weather forecast in your system and look at the weather forecast. It's all built into that hybrid model. And then take data filters and apply data to solve challenges. Like, one of the holy grails of the monitoring that we'd really like that every company was racing to figure out is how to detect PID, degradation in modules. This is something that could be solved by this technology. But in the end, it's really to make the job easier to run solar plants and reduce the cost. That's really what we see this data intelligence will introduce. In the end, it's going to reduce the cost and make operations and management easier and cheaper. So that's my wish for the next generation. If we could just, or for the next generation of solar projects to be built in 2019, is to make them more cost effective, more commercially viable in more and more markets. Like you said, they're already technically viable in a lot of markets, but by reducing the cost of solar and specifically operations and maintenance, then we're going to grow the pie of our business. And in the end, there's room for all of us in the solar industry, all the companies, if we grow the pie. And I think that's going to be the legacy of monitoring technology.
Great. Well, thank you, Anson. If any of the attendees would like to ask a question, now's the time. You can also email that to us, but just raise your hand or chat into the chat box. Anson, you know, as we've discussed, the North American market is a good growth market. It is still early days for especially utility scale solar, but as the market is maturing, and obviously various niches of the market mature with it, like monitoring and control, how do you foresee, how do you keep abreast of what customers want? What is that primary interface for you?
That's a good question. So we I had a interesting conversation at Solar Power International with a customer, and it was on one hand, so we like to think that our software and all software platforms were designed by the users, right? By the customers. All software platforms listen to the needs of the market, and probably all businesses listen to the needs of their customer, and they design a solution for their customers. And I think that's always been true until you get to the point where you introduce technologies that the customers don't understand, and that are beyond the scope of imagination for the customer. I mean, we understand the customer's problems, and we're looking for all ISVs and businesses are looking for solutions. So to answer your question, we ask our customers what they need or what would make their job easier, what are their pains. But I know I keep getting future forward, but we didn't know that we needed email until we started getting it, right? I mean, it's one of those things where now we're in a realm where we're able to introduce technology to streamline solutions to their problems in ways that the customers couldn't imagine themselves. Does that answer the question?
Yeah, definitely. I mean, it is a bit of a rhetorical question. Well, how can people reach you, Anson? And then I will make a couple of announcements, and we'll go to the closing slide.
Yeah, sure. I think email is probably best. It's a.moran@meteocontrol.com, METEO control.com. I work in Buffalo Grove. I live in Chicago, in Uptown. So I try to participate in a lot of the ICEA events. So I think at the beginning of January, they're going to start solar drinks again at Jefferson Tap on the last Thursday of each month. I would love to drink beer and talk some smack about solar with you. So show up and have a beer. That's the best way to get a hold of me, at Jefferson Tap the last Thursday.
Great. Yeah, I look forward to the IC events in 2019. So we have a couple of upcoming events here at Continental. Next week on December 6th is our monthly Chicago Solar and Storage Meetup. You can find information about that on the Meetup platform. And that's the first Thursday of the month. We have an intelligent conversation about solar and storage, answer a lot of questions, and then do a rooftop tour of our 55 kW rooftop array and a peek at our 100 kW battery in the basement. Then on January 29th, we will be doing SolarWorks for Illinois. The topic is Illinois Solar for All program with Program Administrator Vito Greco of Elevate Energy. Elevate is a well-known nonprofit in the Chicagoland area focusing on energy efficiency for multifamily, and now they have been named the program administrator for the block program here in Illinois. And then hopefully on February 26th, we're still ironing out the details, but that's our February 26th webinar, and the topic will be net zero with Shilpa or a colleague, that's TBD, from the Alpha Group. And with that, we thank you again, Anson, and you have a great day, and thanks to everybody who joined us today.
Thank you, Tim. It was a pleasure.
Take care.
Bye-bye.